All right, so Greg has just stepped out for a bit, but in the meantime, I'm Will Sargent. I'm from Lightbend. We used to be type-safe. We're still type-safe, but we're no longer type-safe, if you get my meaning. We just finished working on Play 2.5. Play 2.5 is actually a lot of what we do for Play is actually set up the internals and do a lot of work so that everybody who uses Play itself doesn't have to. And so part of what we did for Play, what we tried to do for Play whenever we are migrating, whenever we are adding new features, is we try to make sure that everything happens in lockstep fashion. So whenever we're doing any kind of work to upgrade features or try to change it from one place to the other, we don't simply delete things if we can possibly help it. We actually deprecate them in the release, going from Play 2.3 to Play 2.4. Each one of these is a major releases. Play has the same version scheme as Scala does, so it's actually epoch major minor, not release major minor patch, and which confuses a lot of people. You'd be surprised when the people who'd be like, you broke this or you deprecated this and it's only a minor release. But the goal is basically every single time that we change something or we delete something, we give warning, we say that this is deprecated, we provide people with a migration guide, we give them step-by-step instructions on how to get from A to B, and then once we're satisfied that everybody is cool and everybody knows the direction that we're going in, then we start removing old code. And that's where we actually get to Play 3.0. Play 3.0 is where we actually start saying, okay, we are going to start deleting things out of the system. And Play 2.4 was actually a big step for us. We learned a lot of things. Mostly we learned a lot of things that we could do better in terms of documentation and in terms of changing and managing people's expectations because we are moving to dependency injection. And so with Play 2.5, we really want to get your feedback on this. We want to see what works, what doesn't, what's going to be clear to people. And we really have put a lot of work in to make this as smooth experience as possible. Okay. So hands up everybody who's worked with Play. All right, cool. Who hasn't worked with Play? Who would like to work with Play? Okay. All right, so we probably don't need this slide quite so much. But just running over the top, Play is full-stack, asynchronous, non-blocking web application framework. You know what most of these terms means, but the biggest one is that Play is a framework. It makes assumptions, and it says, all right, we're going to start off doing everything for you. If you want to change anything, we will let you do this, but we will let you change this one thing without having to change everything else. It's not a library. It's not something where you have to put together all of the pieces and rearrange them in exactly the right order. Play does all of the work for you, and hopefully has set it up in such a way that you only really need to change one thing or a couple of things in order to get it working the way that you would just like. So Play's philosophy is to do the right thing and to do it simply, to not make it complicated, to do the thing that actually works, that actually will scale, that actually will let you grow your system from 1 machine to 5 machines to 100 machines to maybe even 1,000 machines. It's equally important for Play to actually be opinionated about the things it does and the things that it doesn't do. Play is stateless by default. It doesn't try to store state inside of the server. Play is unopinionated about its persistence management framework. It doesn't try to tell you what kind of database you should use. It doesn't try to tell you if you should use a database at all. It doesn't try to tell you whether you should use JavaScript at all, for that matter. It has an asset pipeline, so you can use JavaScript and CSS and everything else should you choose to need it. But it says, whatever you choose to use is up to you. We will make sure that we support you within that framework. And then, of course, Play has to be reactive. We have to be able to fail gracefully. We have to be able to work in a way that makes systems resilient under load and be able to transfer to one to another. So if you have like 50 Play servers and one goes down, we have to be able to make sure that the load is evenly distributed across everything else. So what's new in Play 2.5? The biggest thing is we have Akka streams. We have 20% performance improvement, so we've made things faster. We have better documentation and better templates so that we explain everything internally that's going on. And we have also set things up for Play 3.0. We've set up a reduction in global state, so we don't use singleton objects very much, but where we do, we are slowly minimizing that. We have this thing called play.current, where you can point to a current application from absolutely anywhere. We are trying to minimize our use of that and squeeze it down more. Now that we have JDK 1.8, and we can actually use functional paradigms with Java, we have started taking advantage of that. We started taking advantage of completion stage, and we started taking advantage of the more concurrent utilities that are available in 1.5. And then finally, we've just done a number of things internally to set up the runway for us. So when we have 2.6, we can hit the ground running, not having to do a lot of rework under the hood. Okay. So Greg, do you want to take Akka streams or?
Sure.
Does that work?
Okay.
Okay.
You hear me? Okay. So yeah, another thing that we added, probably the major improvement we added in Play 2.5 is Akka streams. So it's an implementation of reactive streams, which is basically just a way to do streaming with back pressure in the JVM. It has a lot of, Akka streams in particular has a lot of abstractions that allow you to model data flows. There's an abstraction called graph stage that allows you to kind of very easily model all your inputs and outputs. It takes a little bit of time to understand those APIs, but it also has simpler APIs that just allow you to connect sources and syncs together in a very intuitive way. And it's more imperative, which makes it a little bit easier to use than the iteratees that we were using before, which is kind of not as easy to use if you're new to functional programming and you didn't understand some of the paradigms. So we still support iteratees, but we do it through an adapter, and we'll probably break that into a separate library in the future. And the fact that we have the Akka streams is what allows us to do a lot of the new Java APIs that we added. And I guess Will can do his demo of the...
Okay, sure. So this is actually a demo that we set up earlier. Oops. So goes to localhost.
It's a really low resolution.
It's a really high resolution. There you go. How's that? Everyone see that? Okay. And all this does is it sets up a clock that sends the current date and time from the system. And you can see if I scroll all the way up, let's increase the resolution here. Does this increase? Okay.
I think the retina display confused it.
That is a remarkable retina display right there. Let's do displays, and then let's change the preferences. All right. So this actually is a sample play application. We have a lot of activator templates, which are available online. And this one is something that you can actually download from GitHub. And this just shows you when you're using Scala, you can pull an event source flow. You can say, I've got a string. And I can say, send this out through Scala as an event stream here through a single action. This is one line. And the internals here is just sending out a date every 100 milliseconds to update it. And you can do this in Scala, or you can do this in Java just the same way. And the API is almost exactly the same. So doing streaming through Akka doing streaming through Play using Akka streams is actually very simple and very easy to do. All you need to do is get an event source here, get a route, you're streaming the clock, you've got an event listener coming through, and that's all you need to do in order to be able to do event streams, be able to do event server-side events here. Okay. In addition, we have upgraded infrastructure, which we previously said, and part of that is because we're using NetE 2.4. This is a huge change underneath the hood. It gets us closer to HTTP 2 and the underlying binary interfaces. We are using async HTTP client 2 on the other end, which is also faster and has more features. We have the upgraded documentation and migration guide, as previously said. You can actually do this. Oops. You can actually use activate a new example app and then just type play Scala intro. And then that takes you to the application page, which now has links. It now has all of the documentation in here. It now has comments for absolutely everything that you might possibly need. And then we have a search box up here that actually allows you to type anything in and see the integrated text as well. So if you don't have a clear idea of what the documentation is telling you, then any errors can actually be seen in the source code, and you can actually go in and you can just edit the page and then submit that as a patch request as well. So we're trying to set things up so that the documentation is a self-improving phenomenon. Anytime you see something in the documentation isn't there or should work better, you can just go in, edit it, submit it as a pull request, and then we will take it and we will pass it in. Okay.
Yeah. I can do this, yeah. So probably the biggest thing that we changed or that we're changing over time in Play is removing global state. And the problem with global state is it just makes it harder for you to test your application because you have to make sure that state is set up. It makes it harder to define different implementations of the same interface and swap those out for different environments. It makes your code less modular, makes it harder for you to tell like what your code depends on. So if you want to break it out into different modules, it's much harder. So we're trying to make it so that people are kind of set up for building stateless or like applications that don't have that global state in it. So we've also removed plugins, which it was kind of the source of a lot of bugs because when you initialized a plugin, you normally use some global state somewhere, and you have to make sure that your plugins are instantiated in the right order. And now everything is just components with dependencies, and if you want to do stuff at the beginning of an application, you do, or at initialization, you just do that in your component in the constructor, and then you can add hooks to when Play shuts down to do whatever you need to do as well. So that was a really big improvement, and we're going to keep doing that. And by 3.0, we're probably not going to have any global state at all. That's the goal. So I know this is a Scala meetup, but the Java APIs were actually one of the major things that we did in Play 2.5. And now you can pretty much do anything in Java that you could do in Scala before. And for you guys, this is useful because a lot more people are going to be able to use Scala and use the same APIs and easily switch over to the Scala APIs. There's a lot more Play users who are using the same backend as the Java and Scala backends in Play share a lot of the same code. So it just makes the Play community better and much bigger, and it's easier for you to switch between the two APIs.
Oh. Does it not work again?
Do you want to just take the plug out and plug it back?
Sure. The good old computing days.
Let's see if that's yeah.
Oh, there we go.
All right.
Oh, now it's asking if we want to optimize for Crestron. I don't even know.
That's fine. That's just the.
Just minimize that.
Just minimize it. Okay.
Wait, there's a screen inside of the screen?
I can hear the Inception sound already. Okay, here we go.
Okay, there we go. So, what? There we go. Okay, so what's coming in Play 2.6 and 3.0? So obviously, like I discussed before, we're going to remove as much global state as possible. 3.0 will not have any global state at all. And that makes a lot of cool things possible, like being able to run multiple apps or multiple tests in the same JVM concurrently. We're also going to be adding the feature to allow you to tag requests. So if you're in a filter and you want to add some information to the request so that you could use it in a template or something else that's contextual that's specific to that request. One place we would use it in Play internally is for like the CSRF filter to add the token and a bunch of other information that's specific to that request. And that's where that state belongs. It doesn't belong in global state somewhere. You call some global method. It belongs in like with the actual request. Where Akka HTTP already has type-safe headers, so we're probably going to integrate something like that into Play as well, so that when you add a header value, you're not having to worry about dealing with stringly typed things. You're just able to say, here are the possible values of this header, and make sure that it's, you have the correct value for it. We are moving stuff like Juice and some of the other modules into separate modules, so that you don't have to, depend on Juice. You would just add Juice as a separate module, and then we're also going to have other types of dependency injection frameworks, that you could add as a module, and you don't have to have this kind of bloat of extra dependencies. And we're going to have caching for WS, so cache control support, so you can actually cache requests. If you made multiple requests to the same endpoint, you can save that data, so you're not having to transfer a lot of data. And of course, HTTP2 support. And Netty 4.1 is doing HTTP2, so hopefully by the time we release 3.0, they'll have a final release, and we can use that and implement the HTTP2 APIs.
Yep.
Yeah. So
yeah.
you can do.
Yeah, so we have a number of questions for the audience, which is, how are you using Play right now? Are you using Play on the server side? Are you using it on the client side? What works for you? What could work better in Play, or is a particular sticking point? And what features do you look at Play and think it really should have this, but it actually doesn't right now? That is, what do you think Play is actually considered has a gap in its system right now? So if anyone has any feedback or any questions about Play internally. All right. Yes. Good, sir.
We have to integrate a Play application where we're tracking certain information during the processing. The difficult part with Play is how it juggles the threads, and it's hard to pass contact information from basically one thread to another to
Yes.
similar kind of thread local is acting in the regular G2E containers. So any help for that kind of more standard way of passing kind of contextual information from thread to thread?
Yeah, that is actually thank you. That is actually a problem with execution contexts, is that if you're actually passing information between the two of them, it's very easy to invent thread local. So yeah, we do have some subtyped execution contexts where you can actually pass in some state and you can actually pass some state out again, but we don't really have a formalized way of extending that. That is something that I have seen blog posts on that, for example, but that is not something which Play currently does. That is, Play tries to be essentially stateless, and being able to pass things around between different threads is something that usually happens between Akka. So if you have something you actually need to pull in and out of state, etc., then you would have like Akka actors passing messages to each other, and then you would just be able to reference them inside of that. So I'm not sure if that answers your question necessarily, about threads versus having actors, because actors are usually where you keep state. So I don't know if that.
Well, the task is simple. You have different events, and you're trying to capture some statistics about them. Let's say some numbers which you report at the very end of the response.
Yes.
If your request spans so many threads during the time, and it's hard to coordinate that passing around the thread local, special, different execution context.
Yeah.
It would be nice to be able to bring it all together under the same roof, and what's the right way of doing it?
That would be, you would have an actor and you would send that actor various messages to pass it through a finite state machine so that as it got those messages, its state was continually updated. And then finally you could query it to spit back out the finished state when it was done. So you would have a short-lived actor for the duration of the request, not request, but the duration of that statistic. You would actually create a short-lived actor that would exist only until you'd finished accumulating that state. So, okay, yes?
So I know that Play offers all these fancy ACID pipelines like CoffeeScript, etc. And I think they're mostly implemented as SPT plugins.
Yes.
Now, I know there is an Excel plugin for scala.js, but I was wondering if there are any plans to give it more of a native feel to integrate scala.js plugin for Play.
That is something that we have discussed, but we don't have any formal plans for it. That is something where we would, welcome help and any code contributions, but it's not something we'd necessarily have the bandwidth to be able to take on ourselves. Yes. Sorry. Sorry. The question. Okay. I don't know my speakers. The question was: there is a JavaScript, there is a Scala.js plugin for SBT, but is there plans to do something more formal and more native in terms of the integration between Scala.js and Play? Did I have the question right? Okay, good.
Yeah.
All right. Okay.
Any other questions?
I've only played for a very short time, so that's reflect my own ignorance. You said that the routing is a little crude.
Yes. That's a good point, and actually that is something that did change, but that actually changed technically in Play 2.4, not 2.5. And that, sorry, the question was, isn't routing very crude? And the answer is yes.
I didn't think
That's fine. No, the routing was always, when routing was first implemented, it was a straight Rails pass-through from the beta. And so it didn't even take account of anything that Rails subsequently did, like the REST resources or the namespaces or anything else. So when you look at Play now, there's actually something called the CIRD, which is the string interpolation. Yeah, string interpolation router. And what that does is it provides a DSL which allows you to break down a path and query parameters out of a string and be able to extract that. And not only do you have optional query parameters and optional route parameters, but you can actually have things like ID path directive binders and so forth. So you can actually bind them directly to your domain objects internally. And that allows you to write a complete Play application inside of 35 lines. There's a great post by a guy called Lloyd Meta, I believe. I think his blog post is Slimate. You can also find it, if you go to the Play 2.5 tutorials page, we have revamped the tutorials page so that everything is organized, and there is a set of new blog posts stating how you can do complex routing and be able to use Play as a REST API. I think, I only remember his Twitter handle, which is Lloyd Meta, and the website is Slimape, I believe. but don't quote me on that. You'll find it in the tutorials page. It's about halfway down. There's a great new. Actually, let's demo this.
We can just, yeah.
Oh yes,
Go
please.
to
I
it
just got
quickly.
this working today, so I'm inordinately proud of it.
Maybe you can search for it. And,
Yes, let's do that. All right. If we can do it without breaking the website.
okay.
Okay. All right. So now, if you go to the Play documentation, there is this big search box here. And if you type tutorials and you type REST API, all right, so here's REST APIs, here's third-party tutorials, here's Play 2.4, building a simple REST API. And this is actually, oh, it's not that one, it's Minimal Play. Lloyd Chan is the guy, and he shows this is a complete Play application in 38 lines, right here. So anytime somebody tells you that Play is too bulky and too heavyweight, and you can't just write a simple Sinatra-style Play application, show them this page. Because you can do things in Play that are very simple and very streamlined. There's no need for you to necessarily go through all of the rigmarole.
Right, and we're eventually breaking out a lot of the stuff inside Play into different modules, so you don't necessarily need to depend on the entirety of everything that we
Yeah, you don't need
provide.
WS, you don't need
Yeah.
cache. Yeah, everything is modules that you can include or exclude as you want.
Right.
Yes.
You mentioned you'll be working on type-safe headers for Play 2.6. What will that look like?
Wait, repeat the question.
Yeah, so you were asking about type-safe headers in 2.6. What would they look like? Honestly, I haven't given a whole lot of thought to it yet, but Akka HTTP has a fairly good implementation of type-safe headers, if you take a look at what they've done. So it very likely might look like that, where essentially all the the values are kind of made into case classes or into some kind of type-safe value. Yeah.
And is there any plan to improve the forms, Play forms? Like the documentation is pretty...
And I worked so hard on that.
I think some work. I mean, we've done. There definitely is some work that to be done on the documentation. We've improved some of the things in Java forms. I don't know if the Scala form stuff has been touched
Yeah.
in a little while.
I mean, there was a complete re-implementation of the Forms API. That's actually called validation. It's something that Julian Turney worked on.
Yeah.
But that actually turned out to be too much to actually consume inside of a single release. And so we have been putting it off until we can properly document it and release that as well. So yeah, now we know that Forms is one of these sticky UI places where you have to take user input and you have to do something useful with it. And unfortunately, it's kind of like doing UI. You think it's simple, and you think that putting together templates is simple, right up until the time that you actually start dealing with user requirements. And then it's all just horribly complicated in spaghetti code. That being said, there are a variety of useful templates. There's actually a very useful introduction course, actually called ICS, which goes over how to create some of the software. Actually, wait, let's do this. Let's use the form. This actually should be in the tutorials as well, I believe. So the forms page, here we go. Example form, multiple checkboxes and selection, UX-friendly conditional form mapping. So this also goes into some of the Play example forms and how to do complex form handling inside of Play as well. Okay.
Any other questions?
Real good? Yes.
We're using several sub-projects, but it's kind of I've seen several templates they have been different structures. Like on some documentation they mentioned application conf will not be read on those sub-projects. So the question is, are there any plans to have a standard way of organizing those sub-projects? Because I understand Play is using SDT nested build.
Yes.
But do you have plans to introduce them a more standard way?
I mean, SBT is actually There is an SBT sub-project.
You're gonna need to unplug it.
Oh dear. Okay. Yeah, so the SBT, the question was, is there a standard way to do SBT SBT sub-projects? And this is actually something which the documentation does tell you how to do it, but the way to actually do it involves creating a common area and then being able to pass everything through that. So if you look, splitting your application in several parts, here we go, sharing common variables in code, and then you have different sub-projects under this, and that's basically, a lot of what happens from here is building off of SBT, I'm sorry. And so SBT multi-project build goes into a lot more depth in terms of various different ways to do it. Unfortunately, there isn't a standard way to do it because there is SBT, and SBT gives you the flexibility to be able to do it any way you want. So if you have a working sub-project, the best thing to do is look at some of the SBT sample projects and look at some of the play sample projects. I've actually got a couple of them linked again from the tutorials page, and then just be able to reference that. In particular, there's one called Play Slick 3.0, and Play Slick 3.0 has several different modules which isolate Slick and flyaways and some other code from Play, so you can actually load them independently and then call out to them. So that should work.
Sorry, one more.
Yes.
Different one. About security or authentication of Play.
Yes.
I didn't see any reference to like a good way of securing like the REST API. So basically,
Yes.
what we are using right now is the Silhouette module. So do you plan to have like that kind of standard
Yeah.
library?
Yeah. No. That is a good question, and okay, I will repeat the question. The question was, what options are there for authentication and authorization in Play? And this isn't something that Play handles itself officially. I mean, there is a security to authenticator, but it's very minimal. What most people end up using, if they have any kind of front end at all, is Silhouette, if they have a Scala API, or Play Authenticate, if they have a Java API. So there's actually two different authentication plugins for Play. There's Silhouette and there's Play Authenticate. And those are both updated for 2.5, I believe. And on top of that, there's also an authorization plugin called Deadbolt, which has also been upgraded recently. And in addition to that, there's also various different JSON token things that plug into Scala. So as far as you're concerned, you're talking about authorization and authentication as a REST API for Play. That is JWT, JSON Web Tokens, and something called the new security stack, which is, you've got FIDO, and then you've got JWT, you've got signed authenticated tokens, and you have all of that sitting on top of a TLS 1.2 stack, et cetera, et cetera. So that is something that Play doesn't provide for itself. Play provides you with the plugins to be able to do JSON Web Tokens on top of that. But you're right in that the documentation doesn't necessarily tell you if you're going to do this, then do that.
Right. Yeah, and I think that for 2.6 in the future, we want to make a better integration in the documentation with modules, allow actual external module authors to register their modules and kind of show that they're updated and provide descriptions of there and all kinds of stuff like that. But it's not something that we, like authentication, a lot of this stuff, it's not something we want to support directly because there's just so many different ways of doing it. It's hard for us to say, okay, we're going to build an API ourselves to do every single way of doing authentication.
Yes?
You mentioned that you will be removing globals, right? Right now it does provide the lifecycle event like on startup, right? Where you can pretty much do something when the application successfully initialized and about to serve request.
Yep.
Where this event, for example, should go with the new infrastructure.
Yeah. There are a couple different ways to do it.
Oh, wait, that's good.
Oh, sorry.
Question.
You were asking how do you handle lifecycle events like on startup, on stop. So right now, it really depends on what you're doing. The best solution depends on like what kind of initialization you're doing. If you're initializing something specific to some component, like if you have a database component and that needs to do some initialization on startup, a lot of times you can just do that in your actual class, in the constructor of your class. You can do the initialization, and then you can inject an application lifecycle instance and use that to add a stop hook, so that when your app stops, it'll call your stop hook.
Right, but let's say if it fails, right, and during the binding, I have no control to know whether it succeeded or not, right?
If
Because if the binding fails, it still goes.
If what binding fails?
Well, let's say for my component.
Well, if the binding fails for your component, then your application won't even start. If the binding,
Right,
if the
but the other component is still trying to initialize. So pretty much, if there is any point where I can say, all right, all my components are good, I'm good to go.
well, I mean, if you're using Juice or some other dependency injection framework, if the dependencies aren't satisfied, then it won't create the injector. So it shouldn't start at all.
Maybe compile
What do you
time.
mean?
Compile time, maybe.
Yeah, or you can use compile time dependency injection, and you'll know at compile time. But if the bindings aren't satisfied, then it won't create an instance of anything.
Currently, if the binding fails, the either in slash component are still continue initializing, but with globals, it's not triggered at the global level. That's kind of convenient. So at least I know that I don't have to declare that my application is up.
I mean, I guess I don't know exactly what you're asking, but if you want to initialize something, regardless of whether the binding fails, you can create your own.
Vice versa, I don't want to kind of continue if something before me failed, but I don't want to declare explicit dependency on that component.
Right. Oh, okay. So if something, you mean not the binding, if something in the initialization fails.
It's something just throws an exception randomly.
Right.
How do you actually catch that and deal with it in the initialization phase?
Right, and I don't want to run my, let's say, publishing of my service somewhere if something failed.
Yeah.
Before
Yeah, in that case, you actually have like a two-phase initialization. You bring up the things in binding that you know aren't going to fail, and then once you actually have brought up all the things that you know to actually get a running system, you bring up all the things that are going to flake out and throw exceptions on you because they're terrible crap code that has bugs in them. You bring those up like yourself. Like once you've actually finished the binding, once you've actually started the application, then you call out to try flaky application and then just keep trying it until it actually works, and handle that post binding.
Yeah. Well, and another thing you do if you want complete control over how your application is initialized, you just override the application loader, and then you can create the application via Juice or whatever way you want actually, and then after you've instantiated your application, do whatever initialization you need. So that gives you as much control as you need. Yeah.
Thank you.
Thank you.